All right, so welcome everyone to Understanding the 2015 Michigan Residential Energy Code. This is part one of three-part session. This entire session, or the entire series, is approved for 3 hours in continuing ed, GVCI, AIA, HSW, NARI Green, AIBD, Certified Green Professional, and is definitely approved for 3 hours in the Michigan Builder's License in continuing competency. I'll be your moderator today. My name is Brett Little, and I'm the Executive Director at the Green Home Institute. The Green Home Institute is a nonprofit with a mission to make healthier and more sustainable choices in the renovation and construction of the places we live. And real quick, a huge thanks to our sponsors, Anderson Windows, Panasonic, Suntuitive, Serve, all of our members, all of our board of directors, volunteers, and presenters. We couldn't do it without you. All right, so we do have two presenters today. Jeff Kolonowski, who I'll introduce on the third session to cover ventilation. He'll be joining us from Panasonic. And then throughout the session, we'll be guided by our founder and former president, Michael Holcomb. Michael Holcomb is a longtime Energy Star rater here in West Michigan, and has educated thousands of people across the Midwest building better, healthier, more sustainable homes, as well as he helped found the organization and start us off as one of the original Lead for Homes providers back in 2005. Mike is still out educating builders in West Michigan and performing home inspections and new construction inspections and testing on hundreds of homes and units a year. So with that, Mike, take it away.
Good morning. We're here today to talk about the 2015 Michigan Uniform Energy Code, which was adopted on February 8th of this year. So we've got about 10 months of experience with the program and working out some of the kinks, and I think it's a great time to take a look at this program again, whether you've been building under it or whether you're just getting ready to pull permits under it for the first time. I get a lot of calls on a regular basis from builders that either haven't built or started a new home in a long time, and they're trying to figure out how to deal with the new code changes, because there are definitely things that we're going to be doing different. I would say doing different or doing better in building new construction, residential construction. So first of all, if you don't have a copy of the code book, I would certainly encourage you to get one. This is, you can get them through the Michigan Department of License and Regulatory Affairs in Woodland. It's a Woodland Circle in Okemos. It's a website only order. It runs about $44, or you can order them from IECC and in your local HBA. The cost of $118 to $117 or $170 would depend on who you ordered them from, and also your level of membership in those particular organizations. But the $44 cost was available when the code books were rolled out back in February. So that's the place to start. It really is a good idea to have one. So the applicable code is, let's see here. We're going to cover the modified IECC 2015. They did adopt 2015 with modifications. We'll discuss those modifications. The thermal envelope requirements as part of that modification is still tied to the MUEC 2015 or IECC 2015. But the mandatory measures are based on the requirements of IECC 2015. The code will apply to new construction. It applies to remodeling, the additions or alterations, renovations, and even repairs. For the most point on this presentation, we'll be discussing new construction. But if you have questions about remodeling, additions, alterations, or renovations, or repairs, certainly feel free to ask those, and we'll probably cover some of those in the presentation. We've got about 90 to 100 slides to go through, and typically a live presentation, this would be a 3-hour event, so we've broken it up, and we may run a few minutes over that depending on the number of questions that we have. But don't feel that if you're not involved in new construction that this won't be of value to you, because the requirements are pretty much the same. So just ask the questions and we'll make sure that we address those. The exceptions to the MUEC would be some modifications to components of the home, such as storm windows or glass-only replacements. Those are exemptions. If you open an existing frame cavity and expose it during construction, you only have to address it if it's not already filled with insulation. So you don't have to upgrade that insulation if it's already insulated. And you don't have to worry about construction where the existing walls and roofs or floor cavity is not exposed. So those are exemptions to the new code. And but if you do expose those areas, then you have to bring them up to the new code. If you are re-roofing, the roof has part of the thermal envelope exposed, and neither the sheathing nor the roof insulation is exposed, you don't have to deal with the energy code. And if you're re-roofing, it's not part of the thermal envelope, and that's so you have an attic space and you're going to re-roof, you don't have to deal with the thermal envelope requirements. If you're replacing existing doors, you do not have to meet the new code, and that includes vestibules and revolving doors. Lots of exemptions. From a lighting perspective, if you're replacing less than 50% of the luminaries, the lighting fixtures in a space, you do not have to deal with the code as long as you're not increasing the installed interior lighting consumption. So if you're just changing out lamps or fixtures and you're not adding a lot of lamps and fixtures, you're just replacing existing and it's less than 50%, you don't have to address it from a code standpoint. And if you're doing things that only replace bulbs or ballast, then you don't have to be concerned with the efficacy of the fixtures that you're putting into place. These are the exceptions from IECC 2015 that do not apply. And if you just, when you get your code book, if you look at these exceptions under these jurisdictions, paragraph numbers, these tables, they all have to do with things that you no longer have to address. And we can cover those a little later in the presentation. There are predominantly 3 jurisdictions, climate zones that we're dealing with. I don't know if we can make this any larger. Let's see. That may be a little easier to see now. We have 3 climate zones in Michigan that we're going to be dealing with. And that's important because if you take the prescriptive pathway on thermal envelope, they will differ slightly depending on the climate zone you're in. So all the counties marked in pink are climate zone 5A. The climate zone 6A are the areas in white, and the purple are in climate zone 7. So most of the lower half of the lower peninsula is 5A, and the upper half of the lower peninsula and the center of the upper peninsula are 6A, and then 7 are the colder climate areas on the west and east thirds of the upper peninsula. We have 3 different compliance methods for meeting the new code. The first is prescriptive, and that's just a matter of following the book and using the required R values or U values for thermal envelope, attic insulation, closed attics, framed above grade walls, rim band joists, foundation walls, U values of the windows and doors, and just going through and with your code officials saying these are the values that we're going to use, and that's what they inspect to, and then doing the required blower door test at the end, and the mandated duct leakage testing if you have any duct work that's outside the thermal envelope. We'll define that a little bit later. Then there's the performance method, and the performance method is using software that projects the total energy consumption of heating, cooling, and water heating, and if you are below or equal to a projected energy cost for those 3 areas of less than or equal to IECC 2015 or MUEC 2015, then that performance pathway deems to be equal to the code. So if you are used to building with 2x4 construction and you're not sure that you have to go to 2x6, or you don't want to go to 2x6, or you don't want to have exterior sheeting, you can use performance-based code to build the way that you're typically building now, because there's a lot of trade-offs that are allowed. And then there's above-grade programs that if you build to that standard, and I think currently we have the NHB Green program, Energy Star version 3, if you meet those certifications, then you're deemed to meet the code. There's also a HERS index report, which is a national rating index, and if you hit a certain target goal in the rating index, then that also deems to meet the code. And we'll discuss those as we get to them. These are just highlights and kind of an overview of those issues. Let me get this back down to there. If and the Green Home Institute is involved in currently submitting above grade programs to the State Construction Code Commission to see if how many of these we can get evaluated and approved, so that the builders have more options, more choices in building to meet their clients' needs. So near the end of this, we'll be discussing a little bit more on day 3, possibly late on day 2, other above grade programs at that session. But they're performance based. They're equal to or less the cost to heat, cool, and water heating of annual energy costs for a standard reference home. All ducts must be in the thermal envelope or insulated to an R6. There's a mandatory electrical panel sticker that needs to be installed. There's heating and cooling must be sized by manual J and D and selected by manual S. There's air sealing ducts are still required, fan efficacies, and we'll be talking about fan efficacies when it comes to kitchen and bathroom exhaust, and also fresh air ventilation on Wednesday morning. And then recessed lighting must be sealed. You must have a thermostat for each system. You must have mandatory mechanical ventilation, and 75% of high efficacy lighting, which is an increase from 50% over MUEC 2009. There's additional mandatory for in-ground pools, heated garages, and snow melt systems. And one of the biggest issues that is being enforced under MUEC 2015 are the heated garage issues, because if you do want to have a furnace or a heated garage, you must model that in the energy model. So If we're doing blower door testing, which is a requirement, then you have to blower door test the house and the garage. So you would have to have a well-sealed garage overhead door for that to happen, and there's different ways to make that happen. There's cam locks on garage doors, which will force the door to seal around the edges, and there's also sealing thresholds that can be installed to help you meet those requirements. I've only tested a couple of homes where the garage was heated, and both of the particular homes that we tested were able to pass the MUEC 2015 using reduced garage wall insulation, slab edge insulation in the garage, and pass the blower door test, which was most critical. So next we'll talk about insulation and fenestration requirements, and we're going to look at the tables that actually cover the prescriptive pathway. So if you're applying for a building permit, you would have a form to fill out at the, that would be supplied by the building office that says we're going to do the prescriptive pathway, and you would tell them what the R values are and the insulation types that you'll be installing. Quite oftentimes your insulating contractor can fill that out for you so that when you pull the permits you can give that to them. If you're doing a performance-based program as an option to that, then the performance-based paperwork would be submitted in lieu of the insulation certificate that you would be sending up front, because that's what the code officials will be inspecting against. So if we want to look at the code, these are the actual codes out of the current code book, and I just truncated it down so that we can actually review those requirements on a slide. So we have the 3 climate zones. We have fenestration U values, which are your windows, and the only value on a window that they're concerned with is the U value. So solar heat gain coefficient can be any in Michigan because we're a cold weather state, and so the U value is the most important thing. And it's a 0.32 U value is the minimum performance value, and you can have a lower value than that, but not a higher value. So 0.32 is, and that's the overall value of the window, and that's true across all 3 climate zones. If you have a skylight, then the U factor has to be, can't be higher than a 0.55 in any of the 3 zones. So 0.32 on windows. When we first started, most people were used to already putting in a 0.35 window, which was Energy Star. It no longer is in this climate zone. But we're seeing on a regular basis that the windows are falling in 0.30 down to 0.27 on a regular basis. So manufacturers have already caught up to these codes, and it's not difficult to meet that standard. You're probably already building to that standard. Ceiling values, R values for ceilings, and these are attic spaces, are R38 in climate zone 5A, so here in the lower half of the lower peninsula, and then it goes to an R49 in climate zone 6A and 7. And those values, again, are prescriptive. If you're using your performance pathway, they can be less than that, but your particular building plan would have to be modeled to make sure that those values are not problematic. The code also indicates that if you have a raised heel truss, that if you're an R30 in the at the overhangs at the outside perimeter walls, that and the rest of it's R38, that deems to meet the code. So R38 in climate zone 5A, 49, R49 in 6A and 7. Above grade framed walls are they're an R20 cavity or an R13 cavity with an R5 continuous. So if you're doing this on the prescriptive method, if you have a 2x6 wall, you would have to have a cavity fill of R20. So you'd have a high density bat, which I believe in R21 is the one that would apply. The R19 would not count because you have to have an R20 prescriptively, or an R13 bat with an R5 exterior foam sheeting. So on corners, you can have an R3 with your OSB if you need racking strength, or the mechanical code or structural code require racking strength to be applied to the corners, and you can go face that with a half-inch sheet, or an R5 would be the other requirement. If you're in climate zone 6 or 7, 6A or 7, they're both the same. R20 cavity fill, R13 cavity fill on a 2x4 wall with an R5 exterior, or an R20 cavity fill on 2x6. Mass walls, we don't see a lot of mass walls being installed, but the R value on them is R13 continuous or an R17 framed. In this climate zone 6 would be an R15 continuous or an R20 framed wall, and R7 would be an R19 framed or an R21 continuous. I'm sorry, that's the other way around. 21 is the frame cavity. R19 is the continuous cavity. I don't know. I work with about 200 builders, and I don't know anyone that's done a mass wall in probably 10 years. Cantilevered floors. That's the space between a bonus room, as an example, in the garage. That's any unconditioned space, or a deck. 3-season or 4-season room that extends over ambient. So floors, cantilevered floors, R30 for climate zones 5 and 6A, and R38 for climate zone 7. On the basement walls, or foundation walls, and this is the concrete portion of the wall, you have to have an R10 continuous or an R13 framed wall, surface wall. And that R13, the difference is the framing inefficiencies that you have. So if you have an R10 and it's adhered directly to the wall, it could be an R10 sheathing, foam sheeting, which would be 2 inches of foam sheeting. It could be a spray of cold cell foam. 1.5 inches would be about an R10. There's a cellulose blanket that's 2.5 inches. That's an R11. That would qualify for that. There are blankets, fiberglass blankets like pole barn insulation that have been adhered directly to the wall, as long as it's an R10. Or if you have a framed cavity in, it would be an R13 bat or something of that nature. And that's in climate zone 5A and 6A. It is an R15 continuous and an R19 cavity, and it's the same in climate zone 7. And there again, I want to remind you that these are prescriptive values. These values may or may not have to be to this level if you're doing a performance program. That would depend on how the how you normally construct the home, how many square feet, the configuration, all of that type of stuff that's taken into consideration. The values of your windows, the values of your furnace, so air conditioner and water heater. Slab insulation for climate zone 5A is R10 to a depth of 2 feet. For climate zone 5A, it's R10 to 4 feet in climate zone 6A and 7. So that's fairly consistent, except for the depth, depending on climate zone. R10 slab edge. Now you are allowed to taper that at a 45-degree angle if the insulation is on the interior side and you don't want your 2 inches of insulation all the way visible from the perimeter. You can taper that to a 45-degree angle and pour your concrete over the top. That deems to apply. Your crawl space wall insulation is an R15 continuous or an R19 framed, and that's the same in all 3 climate zones. And I think that the reason for that is crawl spaces are typically not conditioned space like your basement would be, so the R value is slightly higher in those instances. There are additional insulation requirements for the prescriptive if you have thermally isolated sunrooms. And that would be a case where a sunroom is attached to the house, but the wall that attaches the sunroom to the house is insulated to meet the thermal requirements of the prescriptive pathway. So it's really an isolated sunroom. Or you have instances, in that thermally isolated sunroom, you're allowed to have a minimum ceiling insulation of an R24 and a wall insulation minimum of an R13. So you don't have to worry about the, on a prescriptive pathway, if you're putting on a sunroom and that sunroom is thermally isolated from the house, you can do these reduced values for both ceiling and walls. And I think that this would be, as an example of this, would be you're adding a sunroom to an existing building. The existing building has a full thermal envelope around it. You don't have to build to this R9 or R38 ceiling standard with an R19 or an R13 with an R5 exterior. So a little easier to add a sunroom. If you're building new construction, you can insulate to these levels as long as the connecting wall meets the prescriptive requirements of, or the performance requirements of MUEC 2015. When you submit your calculations, you can either submit them using R values, or you can use the equivalent U values. And these U values are the prescriptive U values if you're going to use them. Some insulation contractors will submit U values as opposed to R values. So these are what the prescriptive U values they'll be looking for. So your ceiling insulation will be a 0.03 in climate zone 5A, or a 0.026 in 6A or 7. Framed walls will be a U value of 0.057, and that is in all climate jurisdictions. And basically the U value takes into consideration the entire wall assembly as opposed to just frame cavity fill. So if you have an architect or an insulator that wants to calculate those assemblies for you, those are the values that you would be submitting. Floors, the cantilevered floors are 0.033 for 5A and 6A, and 0.028 for climate zone 7. And there again, that's going to take into consideration the floor sheathing itself, and then any soffit material, and then the cavity insulation and any air gaps and those types of things are all calculated into those U values. U values used to be used with ResCheck, but the last I had heard that ResCheck wasn't being used for MUEC 2015 because it had been coded for variations from IECC 2015. And since Michigan is a hybrid program from IECC 2015, ResCheck wasn't being used anymore. There were a couple organizations that were trying to fund having ResCheck model, and to my knowledge, that hasn't happened yet. Equivalent U value, basement walls, 0.059 for climate zone 5A, and 0.050 for 6A and 7. And crawl space walls, 0.055 for all code jurisdictions in Michigan. One of the bigger changes this year is the requirement for an air barrier, both interior and exterior air barriers. There's a chart in the code book that explains where these need to be. Some jurisdictions interpret it a little bit different. We've seen that kind of being worked out over the past 10 months. The biggest issues were rim band joist, and the interpretation spelled out in the code is that the rim band joist installation will have an air barrier both interior and exterior, but we have seen that some code jurisdictions haven't been enforcing that. So they haven't, they started out where everybody was putting in, was foaming initially, and then somewhere along the line, some of the jurisdictions were reading it differently and interpreting it differently. And we've seen some exposed fiberglass insulation in 2 or 3 jurisdictions. I work in about 14 or 15 jurisdictions, and a couple of those have not been enforcing the interior air barrier in all cases. I would caution you against having exposed fibrous insulation in your rim band joist, and not from the concern about whether or not your jurisdiction is going to require that insulation to be covered, but because you have reduced air leakage requirements on the home, and we'll talk about those reduced requirements, but with 80% of all heat loss through convection in a basement is the rim band joist. If that doesn't have a proper air barrier up there, then there's a real risk that you won't pass the mandated air changes per hour when the blower door test is done. And the last thing you want to have happen is to a third party come in to do the blower door testing on your home, which is required on all new construction, and not have it pass. And we have unfortunately had that in some instances. So it's a couple of $100 extra to foam rim band joist in most homes. Of course, that depends on the size, but it is money well spent, not only to ensure that you're going to not have an issue, that you won't have an issue with blower door testing, but also over the life cycle cost of operating the home. Those interior air barriers make a big difference in the energy performance of a house, and they improve the comfort level, because that cold air in Michigan is no longer seeping in at the rim band joist, which has a tendency to cool the floors. And when the floors are cool, then the customer has a tendency to be uncomfortable in their home. So the code specifically calls for a fully aligned air barrier on the exterior, which would be your OSB siding, and on the interior, it's spelled out in the chart. And that would be any insulation that's exposed be covered. So fireplaces, interior wall of fireplaces, tubs, shower surround areas, rim band joist, cantilevered floors on the end need to be sealed. Very important issues. Most of the builders that I work with are spraying those rim band joist areas with 3.5 to 5.5 inches of open cell foam, depending on the manufacturer. That is a qualified air barrier, or others are spraying 1.5 inch closed cell foam, which is an air barrier across all manufacturers. So be mindful that your code may or may not, your code authority may or may not enforce that, but it's in your client's best interest and your best interest that you go ahead and consider doing that, so that you don't run the risk of failing your blower door test at the end. This is a copy of the inspection sheet that most HERS raters will be looking at for fully aligned air barriers. And this is a cutout of the Energy Star version 2 checklist, but it gives you an idea of areas that your insulation needs to be fully encapsulated. So walls behind showers and tubs the insulation has to be kept in the wall cavity. And the purpose of these interior air barriers is to keep that insulation in place. So if you think about gable walls on vaulted ceiling areas, you have a gable wall that's typically in contact with the attic, and it used to be that they would just staple fiberglass up on one side of that and then insulate the attic, and that would be called good. But what we have found is that that insulation has a tendency to fall out after a period of time. And over the years, I've done literally thousands of home energy evaluations on existing homes, and that's number one area that we have to have corrected, because that insulation has fallen out. And you'll oftentimes see that in existing homes because the cavities on the inside will show up on the drywall as being black or dark gray because of micro condensation on the interior wall side, or ghosting stains, which are called by carbon products that are in the air from candles or cooking and that type of thing. And those particulates that are in the air played out on the colder areas. So it shows up, people think they've got a mold problem or something, and it turns out that it's an insulation problem where it's falling out of the attic. So knee walls on the back side, you think of a bonus room area in the garage where you've got the exterior walls are exposed on the attic side. That insulation now has to be covered. So if you sheath those walls with OSB from the garage side or foam insulation, and then they can come in and install their wall insulation like they normally would, that would deem to apply. It has to be a rigid barrier. You're not allowed to use house wrap as an air barrier in those areas, or you can spray it with foam. Foam's an air barrier, so that would be acceptable. Skylight shaft walls are another important areas. The walls adjoining the front porch roof, staircase walls, double walls need to be fully insulated and air sealed on both sides. Cantilevered floors, obviously, at the edge. And in the attic where you have exposed insulation at the floor joist, if the full attic isn't insulated, then those rim band joists would need to have an air barrier in. So you'll have access to these slides, and just be aware that that's what your third party will be reviewing. I can't say for with any degree of certainty what the code officials will be looking at, because they interpret them differently from each side. If you have a bulkhead, you now are required to have an air barrier at the top of that so that the insulation cannot fall into there. And that has to be a rigid air barrier. It used to be that we would have cardboard or even fiberglass bats with the paper face down to hold the insulation in place. And there again, that's another area that has a tendency to fail when especially when it's an attic and there's extreme temperatures differences and also moisture differences in an attic that break down the paper or cardboard and cause it to collapse. So a piece of drywall up there, or OSB or foam to hold the insulation in place, will ensure that you don't have a failure later on, and that is a requirement of the new code. This is the gable ends that I was talking about earlier, and in this particular one, you can see that they put a blue board up there before they framed, and this framing is traditional framing. So you've got a full 3.5-inch cavity on this particular wall. I'm assuming that's a 2x4. But you can get the full insulation in there and still have the R5 on the exterior, which meets the prescriptive method. Where you have a difficulty meeting the prescriptive method is if those 2x4s are flat and you only have 1.5 inches of insulation in the cavity, to keep it fully encapsulated, you can't put a 2x6 bat in there as an example, or an R20 bat in there and have it exposed on the other side and still have a rigid barrier on the back side. So if you're going to have that type of a wall assembly, you're almost going to have to take the performance pathway so it could be modeled at a lower R value, but you still need that air barrier in place. These are tub and shower walls, and you can see that there's a Thermax board on the back side that can be drilled and filled with cellulose or whatever. What we're finding is that many insulators are taking a shortcut, and they're using that fiberglass enclosure as being an air barrier, and it's going to keep the insulation in place. What we're finding out is that your code jurisdiction may accept that, but we're finding out that when we go in to do an air barrier inspection or the insulation inspection, that that insulation is already moved and has dropped down into the floor space underneath the tub, and at some point that's going to cause a failure. And you don't want to have failures because you're ultimately responsible. Even if the code inspector accepts that methodology, if it fails, you're going to have to correct it. So that's a proper way to put an air barrier in to make sure that your insulation stays in place. So you would want to, if you're going to do cellulose as an example, you'd want to put that air barrier in so that when the plumber comes and slides your tub in to place, your tub enclosure, that board is already in place, and then the insulators just have to drill that to do their infill of insulation. And on the tub, you can see there's an air barrier that is outlined in blue. That is a great place to, that's where the air barrier would be required there, and obviously above the tub, the air barrier would be the interior drywall. So, two great examples of things that you may be doing differently, but under the new code you'll want to address. And the next slide, we're addressing fireplaces, and the insulation has to be fully contained within the fireplace with an air barrier. And the one on the left side doesn't have an air barrier. It has fiberglass batt insulation. And what we're trying to keep the cold air intrusion and also the insulation from failing. Since there's big temperature differences, paper-faced insulation will have a tendency to sag and fall out. So you put a thermoply air barrier or drywall air barrier, as is shown in the second picture with the stepladder, as an improved method of keeping your insulation all in one place. Some of this stuff may have to be thought about before these areas get enclosed, because it's more difficult to install an air barrier once all the framing's in place. So some of that will have to be done by the framing crew or by the builder prior to getting that fully enclosed. When we first started doing this with code officials, this training, we were, let's see if I make this a little bit smaller. There's 3 or 4 different examples of rim band joist insulation. And the first one on the top left is closed cell foam, which does a great job of odd cavity fills. And it's an air barrier at 1.5 inches. If it's 5.5 inches of open cell foam, that would also serve the same purposes of being an air barrier, but it's great at odd cavity fills. You don't ever have to worry about that insulation falling out or not fitting properly or leaking during the blower door test. It expands in those small cracks and crevices and does a great job of air sealing. In the bottom right-hand side, you see the pink board where actually someone has cut the Owens Corning foam sheeting and sealed it in place with low expanding foam around the perimeter edges. That's much more time consuming to cut a piece for every rim band joist than the spray applied foam is, but it's an allowed method. The 2 of the red circles with the slash through them are exposed fiberglass, and the code is written that is not supposed to be visible. Whether or not it's enforced is up to the local jurisdiction, but if it's a performance-based home or a prescriptive-based home, it's still going to be looked at, and the potential for failing your duct blaster or your blower door testing is extremely high. And if you use cavities for your return air ducts, they will communicate directly with that fibrous insulation and certainly lead to more duct leakage to the outside. So whether or not your code jurisdiction is going to allow it, is one thing, whether it's good building practice is quite another. So I would recommend that you have a fully aligned interior air barrier as is spelled out in the code, and get a better performing home for your client and less callbacks and less potential for failures when it comes to blower door or duct leakage testing. Here's an example of properly aligned insulation underneath the stairwell on the concrete foundation wall. You're to have that fully insulated. And in this particular case, they have a thermoply, which is, has a cellulose insulation blown in behind it. But you also could use rigid foam insulation. You could use spray applied foam in those instances. But that insulation has to is required to be on the foundation wall underneath the staircase or behind the staircase. And then the proper way to seal the bottom plates to the walls to meet the new requirements for air infiltration is to seal the bottom plates to the walls. And then the garage ceiling, you are required to have the insulation in contact with the floor for the life of the insulation, so you have to install that insulation in such a way that it stays up there. So dense packing it with cellulose is a way to do that if it's put in at a proper density that it can't settle. You could spray foam directly against the floor so it stays up there. If you use fiberglass bats, then you have to have straps to hold that insulation in place so that it can't sag over time, and it spells it out in a prescriptive pathway on how many straps are required and for fiberglass bats. Friction fit insulation will not stay in place just from movement of the floor, from contraction and expansion, from heating and cooling differences to foot traffic. So dense packed insulation, whether it be cellulose or fiberglass or a foam that's attached directly to the floor, or if you're going to use a batting insulation, then you have to have some sort of a suspension system to hold that in place. These are penetrations through top plates going into unconditioned spaces, and the fire code has long required that you have a fire stop in those spaces, whether it be pipe penetrations, wire penetrations, and so you could either use a fire-based caulk or a fire-based low expanding foam, and any of those that have been red or pink or orange have been fire rated. They used to use fibrous insulation, fire rock material to seal that up, and but that doesn't meet the air sealing requirement. So you're going to want to use a foam or a caulking that is fire rated for that, for any penetrations through the framing that goes into unconditioned spaces. So there would be attics or unconditioned crawl spaces. Those are the two areas, and this is a proper way of doing that. The code also has a requirement for the window fenestration leakage, and the code is written, and this is mandatory, fenestration air leakage for windows, skylights, and sliding glass doors, that they have an air infiltration rate that is no more than 0.3 CFM per square foot of window assembly. That works out to 2.6 liters per second per meter squared, and it'll be on the fenestration sticker, and the arrow points to where that says air leakage, and that is the National Fenestration Rating Council sticker. That's a third-party evaluation of that window, And this one, it meets the standard. It shows it at 1 meter per second per meter squared, or 0.2 CFM per square foot. And so that's under 0.3, and so that would be an allowable air leakage rate for that window. That window has a 0.35 U value, which is top left, upper top left number, which is not acceptable for the new code. The new code is 0.32, so that wouldn't meet that. However, that window could be used if you did the performance pathway instead of prescriptive pathway, and the home energy model on the home showed that the heating and cooling and water heating costs would be equal to or less than the reference home under IECC 2015. Those window stickers, this is from a lessons learned, are oftentimes removed when they're installed. And that's problematic because the code officials cannot verify when they come through and do their inspections. They can't say, well, you're using prescriptive, I don't know if that window meets the prescriptive method, or the third-party energy rater needs to come in and look at them also if they're modeling your home. So they have to verify that that sticker meets the requirements. And if you don't have that sticker on the windows, then they have to model at a much higher U value than you might have actually installed. So make sure your installers leave those stickers on the windows until your code official and your third-party rater have been through to verify that. We typically will, when we do our inspections, we come and do pre-drywall inspections, so the walls are insulated. Then as a third-party rater, we'd like to be called in so that we can look at the quality of the installation, we can look at the quality of the air barriers, and we can collect the predominant one predominant window sticker for our files so that we know that you've met those requirements for our energy model, and the code official knows that you've met it for the energy model or that you've met it for the prescriptive pathway. We have been in homes where every sticker was removed when we have gotten there, and the builder has had to go back to their suppliers to get stickers, new stickers to affix to their windows so that they could pass the code inspection and also the performance inspection requirements. So I know that you don't like to leave those stickers on the windows any longer, but please leave them up long enough for the code officials and your third-party energy auditor to evaluate and to see what you've actually installed so that it doesn't cause problems with passing the energy code. One thing that's new with MUEC 2015 is that every building or dwelling shall be tested and verified as having an air leakage rate not exceeding 4 air changes per hour. Now this is quite an improvement. The International Energy Construction Code for 2015 is 3 air changes per hour. Michigan's old code, MUEC 2009, was 7 air changes per hour. So this is a modification. Michigan settled on 4 air changes per hour, and I think that that's a reasonable compromise, because if you're going to introduce that drastic of a change, we need to make sure that they have a shot at passing that. 4 air changes per hour is not really difficult if you're diligent in your air sealing, and you do air seal or put the thermal or the fully aligned air barrier on the inside, and I'm talking about rim band joist areas and the tubs and those high leakage areas. If you make sure that those thermal or air barriers are in place over the thermal envelope, you should not have any problem meeting 4 air changes per hour. When we do performance testing, we actually have to send, with our final compliance report, we have to send the air infiltration report along with that, because the jurisdictions, code jurisdictions have to have that in their files, because they're subject to federal oversight on their performance as energy code officials under MUEC 20 or IECC 2015, and that happened when several of the states took bailout money back in 2008, 2009. This was one of the requirements. They had federal oversight. They had to adopt IECC 2009. This is one of the requirements that was in that they have the paperwork to back this up. So that air leakage requirement is fairly significant, and where most air leakage is found is around fenestrations, and so using low expanding foam around windows and doors in any penetrations is the best way to reduce that air infiltration. Can lights are another huge leakage area. When we test homes with a pressure pan, we have found that you can get as much as 30 CFM at the test pressure leaking through a single can light. So if your home has to have can't exceed 900 CFM of leakage and you've got 30 can lights, you literally, if they're not well installed and sealed and gasketed, you easily could exceed 900 CFM just through can lights. So air sealing is going to be critical. And when we're testing the home, what we do is we open the exterior door, either to the garage or to the house. And if it's in the garage, then we open the overhead doors in the garage. We put a gasketed fan in that door opening, and you can see an example of that fan with the gauges on it. And we depressurize the house to 50 pascals. Now, 50 pascals is the equivalent of a 20-mile-an-hour wind on every surface, including the slab and the roof. And it equally pulls air through any penetrations to that thermal envelope and exhausts it out through the fan. And based on the aperture opening in the fan and the pressures between the interior and exterior of the house and the pressure across the fan meter will actually tell us how many CFM of air leakage that we have. And when we do that test, we have exterior windows, doors, fireplaces, all closed, but they're not sealed beyond being normal. So you want your door seals in. For the doors that you're not testing through, you want to have your window locks and seals in place. You want to have your fireplace dampers closed, but not the fresh air intake, because that's normally left open. Your dryer vent is left in its natural position because it'll have a gravity damper on it anyway. And your dampers for flue and makeup air and intake and exhaust, they should be closed, but not sealed beyond their normal sealing method. And then all your interior doors are typically left open to the inside during the test. And your exterior doors for continuous ventilation systems and heat recovery ventilators shall be closed and sealed. And then your heating and cooling system will be off at the time, but they must be installed, but they are not in the off position. And your supply registers and grills will all be in the open position. And what that does is gives us total leakage of the building at 50 CFM, and we divide the amount of air being leaked by the volume of the home, and that comes up with a number that we input into our software, or we actually do the calculations for the prescriptive testing, and you must be at 4 air changes per hour or less. The average home with exterior sheeting and a well-sealed rim band joist is around 3 based on our testing. I've only had a couple of failures this year, and it both happened to be homes that didn't have the rim band joist sealed, that the code jurisdiction did not. They passed it with exposed fiberglass insulation, and the air sealing behind it must not have been acceptable. So pay attention to that, because that's, air sealing is going to be critical if we're going to pass this test. Recessed lighting. This is another area that is problematic. All recessed lights shall be insulation contact rated, and labeled as having an air leakage rate of not more than 2 CFM at 75 pascals, and that's tested in the factory. We test them at 50 pascals, and we're not really testing that individual fixture. We're looking at the accumulated leakage. But I would not rely on the gaskets for doing a great job of sealing. My recommendation would be that you foam between the can light and drywall compound, and you do that with a fire-rated caulker sealant, low expanding sealant, to keep that air from leaking around the can, because that's where most of the leakage is. It's not through the can itself, it's mostly around the can. And if you're really feeling like doing an exceptional job, consider sealing the can light from the attic side with a cover. There again, make sure that you meet the requirements of the manufacturer as far as clearances are concerned on that cover. Another change is high efficacy lighting. If you think back to 2009, the requirement was that 50% of your lights had to be CFLs, basically, at that time. And they've changed that now to call it high efficacy lighting, and they've defined high efficacy lighting as being lumens per watt based on the size of the fixture. So if you look at these numbers here, let's take an example, the 50 lumens per watt for lamps over 15 watts. So between 15 watts and 40 watts, you have to have lamps that have an efficacy of 50 lumens per watt. Well, you'll find that all compact fluorescents and T8 or smaller diameter fluorescent lighting meet that efficacy, but so does LED lights. LED lights will qualify for all of that. Most of the homes that we're checking are now pretty much 100% LED lighting or CFLs that contractors are putting in, rather than trying to figure out what 75% is. But this includes exterior lights, garage lights, basement lights, and lighting throughout the home. And if you have a lot of incandescent lights, chandelier type fixtures, every bulb is considered a light, and so that would be just taken into consideration for that 75% calculation for high efficacy lighting. That's what we're going to be looking for, 75% up from 50%. LED lights automatically comply, CFLs typically comply, and all fluorescent tubing of T8 or smaller comply. So we're at the end of our hour, and I think that we can break here and take questions if anyone has them. Brett, I see that we see your neck here, Brett, if your camera's on. You want to, do you have any questions, Brett, that have come in?
Hey, everybody. Sorry, I clicked the wrong button there. Yeah, I don't see any questions here, but we do have some time for some questions. So if everybody wants to just drop a few things into the chat. I was taking some notes down too, and I might have had a couple questions, but let me just double check here. While you're putting your questions into the chat box, everybody will tomorrow be covering the mechanical section as well as the performance pathway and some of the above code items we might be wrapping up to Wednesday, and then we'll be jumping into ventilation options and strategies with Jeff from Panasonic. And as far as the quiz goes, or the survey goes, we'll be sending out a final survey on Wednesday at the end. So make sure to take that too, along with the CEU items. Well, Mike, I don't, it looks like you...
Am I still live?
What's that?
Okay, I just want to know if it's still live. Well, I was saying, if there aren't any questions today, or if you come back with questions, Brett, can you, do you have our contact information slide handy that you could put up, or is that something I could put up? I don't know where it's at. But you could send your questions in, or you could save them for the next session. On Wednesday, the first half hour or so, they will be covering the ventilation strategies. As he said, Well, and then after that's done, we will still be doing a bit of a recap, and we'll be answering any questions that may have come in. There's my email address if you want to write that down and send any specific questions. I'll make sure that they get carried to the end also for the purposes of the training. And I know that this is a lot to cover, and it's more difficult when you don't have face-to-face and questions as you go through. But if you do have any questions, please send them, and we'll follow up on them. And we'll do the recap at the end of Wednesday to make sure that we cover those, and also cover any lessons learned on the ventilation issues, because that has changed quite a bit since the code has been implemented. So, other than that, I appreciate your attendance today, and we'll look forward to talking tomorrow morning at 9 o'clock.
Yep. Thanks, everybody. Thanks, Mike. And look out for the email link coming your way for tomorrow's session, which will be different than today's. Take care.